Astronauts call the feeling of weightlessness in space one of the most fun, but at the same time, one of the most unnerving of feelings.
I took my gloves off and they were just like floating there in front of me, and I took my helmet off and I floated my helmet there in front of me and put my gloves in my helmet, and it's very distracting at first. The feeling of floating around and being with no gravity, it's a sensation that's, it can be very euphoric. And it's also very provocative when you first get there. It's a little unnerving to the senses because your body is trying to figure out which way is up, because every way is up.
But it turns out there's another downside to zero-G, because gravity is not just a force pulling us to Earth. It's also a signal, telling the body how to act. Gravity tells the body how strong it needs to be, and without the pull of gravity, there's nothing for the bones, the muscles, and even the heart to work against. So the body perceives it doesn't need as much bone and muscle. Studies show bones atrophy in space at about 1% per month. Muscle mass vanishes at 5% per week. Ironically, the bone and muscle loss that happens to astronauts in space are the same issues that happen to all of us as we get older.
Our motto is off the Earth, for the Earth, So everything we're doing, all the science we're doing on the space station is to return it to the Earth, to make life better for humans here on our own planet.
That makes the International Space Station a perfect lab for testing therapies to help an aging population. The knowledge will also help prepare astronauts for long space flights to Mars and beyond.
If it's the human body, you can try to understand why astronauts come back with bone and muscle loss and how it may affect how we treat osteoporosis on Earth. Anything that microbes, you can study immune system. Why do the astronaut systems become so much like what we see in aging populations on Earth? And so, given the system, there are a variety of things that you can study and learn something new about.
Astronauts exercise daily to maintain muscle mass and bone strength. They're also monitoring dozens of experiments, testing new treatments for osteoporosis or rapid bone loss.
So we tested 3 drugs in various stages of development.
Ted Bateman is an associate professor in the Joint Department of Biomedical Engineering at North Carolina State University and the University of North Carolina at Chapel Hill.
It's a small piece in the drug approval process, but there's definitely opportunity.
He's flown dozens of mice on board the space shuttle and space station, working with pharmaceutical companies to test new medicines that slow bone loss and promote bone growth. One of those medicines has been approved to treat osteoporosis.
The bone loss in spaceflight is much more rapid than what humans experience on Earth. Let's say 5 times the rate of a postmenopausal woman. If we're going to compare men to men, it's 10 times the rate of bone loss that aging men will experience. And then we've got the component of increased bone resorption and decreased bone formation, so it gives the opportunity to test all sorts of potential therapeutics.
The International Space Station orbits 250 miles above Earth. It travels at 5 miles per second. The football field-sized space outpost orbits the planet every 90 minutes. So, for scientists who dream about doing research in a one-of-a-kind laboratory, either testing pharmaceuticals or inventing new materials, the National Lab on the International Space Station is about as cool as it gets.
So the big difference is microgravity, and microgravity enables a lot of phenomena that literally you can't replicate here on Earth. The other really cool thing is the astronaut is your lab tech.
There's a magical thing that happens when you can grow things in 3 dimensions. When you think about it, you take just like water and you pour it on the floor, it goes flat into a puddle. Well, in space, it's 3-dimensional because you have no gravity. So think about that with refining processes or building pharmaceuticals that help us battle these diseases we face here on Earth. Our methods of transporting things in the bloodstream that we can investigate without gravity to say like, hey, so we're hoping that those investigations unlock things that we never knew about our hardware, about our software, about our science on the Earth.
Which is why NASA is recruiting companies to literally think out of this world and consider science in space. The goal is not only to improve life on Earth, but also set the stage for future space exploration.
I think the ideal right now is we're sort of at the advent of just like opening up, just throwing open the doors of discovery on board the station when we turn that gravity switch off.